In this video, I will reveal the dirty secret behind cheap forging codes, uncontrolled heat. A few degrees can turn a smooth launch into a field failure. Hi, I am Rahul Agarwal from Prestech Forgings and Engineering Private Limited. If you source forgings, this is the risk you rarely see until it bites. Your cost is a squeeze, cost targets, PPAP dates, audits. Two codes look identical on paper, same drawing, same material, same delivery timeline. But one shop controls heat with discipline, the others goes by color. Choose wrong and the savings shows up later as a downtime and claims. You are not buying metal shapes, you are buying a controlled thermal journey. Price is visible, heat is invisible. Most ugly failures trace back to temperature control. Overheated billets, decarburization, uneven microstructure, sloppy quench, or lazy temper. None of that shows on a caliper. All of it shows when your part is stressed. Press tonnage and chemistry would not save you if the heat history is chaos. So use one principle by proof of heat control. Two questions to ask every time. What is the window? Exact temperature bands for billet heat, die preheat, finish boards, quench starting temperature and tempering temperature. Who measures them? With what and how often? Evidence: last 6 months data, pyrometer calibration, furnace uniformity results, temperature charts, quench media concentration and agitation logs, hardness traverses, surface to core, microstructure photographs, decard depth. In PPAP, demand trends over time, not single point passes. Red flags: we go by experience, missing logs, expired calibration. The good signs are ranges, instruments, names, timestamps, and trends. The cheapest forging is often the most expensive lesson. Next time you evaluate a supplier, ask yourself, can they show last month's heat and quench data in 5 minutes? What is the one silent risk you uncovered from a great price supplier? Share your story or question below. See you in my